Hello everyone. So today we are going to see about semaphore in C++, how it is implemented and how to use it. So in C++, semaphore is present in this header file. So semaphore. So let's introduce in C++20 only. So we need to use C++20 compiler, then only it will work. So in C++ we have two types of semaphore. C++ we have two types. So one is binary semaphore and a second one is counting semaphore. Okay, so first one is binary semaphore and second one is counting semaphore. So we have two types of semaphore. So first I will tell about what is binary semaphore. So usually, what is semaphore? I already have explained you that what is semaphore. Semaphore is nothing but a counter, and anything can acquire or release. Acquire means it will decrement the counter, and the release will increment the counter. And whenever a thread encounters the acquire at semaphore count equal to 0, it will be blocked. So here, uh, in binary semaphore, the count can be maximum 1. So if we acquire, it will become 0, and if it is released, it will become 1. So it will have only two states. So binary semaphore have only two states, either 0 or 1, and we have to initialize with any initial value 0 or 1. So whenever it is acquire will decrement counter, and release will increment the counter. Okay, so on releasing, whenever we release after it became 1, and if we release again and again, it has no effect. And if we acquire at 1, it will become 0 and proceed, and if we try to acquire after 0, it will be the thread will be blocked as usual. So this is binary semaphore. And what is counting semaphore? So in counting semaphore, so counting semaphore is nothing but a semaphore, as I mentioned earlier. So here what we can do is, so we can set the maximum count to the semaphore. In binary semaphore, the maximum count is 1, but here we can set any value, like any value. And if the semaphore reaches that count on release, it won't get incremented beyond that maximum count. Okay, so after it exceeds that maximum count, release won't have any effect on that count. And acquiring upon 0 will wait as usual, as normal count, like semaphore. Okay, so this is about binary semaphore and counting semaphore. Binary semaphore will have only two states, 0 or 1, and counting semaphore will have a maximum count. So that is like maximum number of threads which can access that using semaphore. If that reaches, if we try to release beyond that count, it has no effect, and if we try to acquire at 0, it will be waiting, the thread will be waiting. Okay, so we will see a code example for this. First we will see example for binary count. Okay, so I have already written the program. So if I write the program it will take time, so I have written the program. So I'm going to copy paste it. So this is an example of binary semaphore. See, the semaphore is included in the hash include a semaphore header file, and I have declared binary semaphore, and we have to have an initial value in the constructor, either 0 or 1. So 0 means upon acquiring on any thread, if we try to acquire this semaphore, it will wait until it is released. Okay, so I have created a shared counter, shared resource here. So in main function I'm creating a function like a thread, and it is running this one. And the shared, here I'm using the shared in main thread, and I'm sleeping here for 2 seconds, and I'm releasing, and inside this one function I'm just printing the some statement and acquiring it and using the shared resource. So the main intention is, so here itself I am initialized with 0. That means it is binary semaphore allows only one thread. So already one thread has acquired this. This meaning of this is already one thread is using this as acquired this semaphore, so it became one. So I have created the semaphore for this shared resource int shared. So this main thread is already using this shared. So this std thread t, inside this I am acquiring this semaphore, but it will wait here because already it is 0. That means main is already has acquired the semaphore, and it is sleeping for 2 seconds. Until it is released, it will wait on the bs.acquire in fun function. So that's why I have written this print statements, and then once it is released, it will continue, this thread will be continued, and it will print the fun have acquired semaphore, and it will give me the shared resource. So I'm going to run this now. See, main main thread acquired semaphore. It is printing initially main thread has acquired semaphore. Then it is sleeping for 2 seconds. Just to show you that here the T thread is waiting in BS on acquire, to show that I have put sleep statement in the main function. So here it will be waiting, and then only this fun has acquired semaphore will be printed. So to show you on a semaphore 0, when we call acquire, it is waiting. So to show you that, that's why I have added a sleep statement. So if you see on acquiring semaphore on counter 0, the thread is blocked and it is waiting. Once it is released, then only it is running. So this is about binary semaphore. This is about binary semaphore. And one more thing, this binary semaphore can also be used to signaling, not only for uh, control the access of shared resource, but it is can be also used for signaling. So once some process is done, then only the thread should start, something like that. If you want, we can declare a binary semaphore, and we can initialize with 0, and we can call the release in main thread, so that we can put the acquire statement in the other thread function. So once this main has called the release, then only the thread will continue. So this can be also used in for signaling also. So this is one important thing we need to note it down. So this is about binary semaphore. So now I will provide you an example for counting semaphore. So I am going to delete this binary semaphore code. So this is code for counting semaphore. So I have declared a counting semaphore with count 3, initial value 3. So that means I have a shared resource of I have a shared resource and can be accessed by maximum 3 threads at the same time. So I have declared an array of size 3, and three threads can access that resource, and one thread can access any one index which is not accessed by other thread. So that's how I have written the code. So this is the boolean array to check which index is used when any thread accesses the shared resource. So I have written a mutex and shared size 3 I have declared. So inside main I have initialized the array to false, and I have created 4 threads, and all the threads are running fun function. Inside fun function I am acquiring the semaphore. So initially 3 can acquire and it will become 0, and the 4th will be waiting. I inside it before accessing this shared resource. I am locking using mutex, and I am unlocking at the last. And if this shared resource currently used is determined to check which index is used by which thread, whichever is false, that is free, that is not used by any thread, so that will be changed to true, and that will be used, that will be modified by any thread, and it will be unlocked, the mutex will be unlocked. And again I am changing that to false. So once everything is done, I am changing to false, and I am releasing the semaphore. So all 3 threads can access, and 4th thread will wait upon bs.acquire. So that's why I have kept a sleep statement inside this function. So let's run and see this program. So if you see, I'll increase it. So thread ID, so 3 threads are accessed, and 4th thread at it is waiting for 3 seconds, then only the 4th thread is accessing the index 0. If you see, 3 threads are accessed and 4th thread is waiting here. Finally, after 3 seconds only, the 4th thread is able to enter the bs.acquire. So 3 threads have acquired the semaphore and it became 0. So the 4th thread T4 is trying to acquire the semaphore, but it is waiting. So that's why there is a long waiting here. So this is about counting semaphore, and I have already told you any thread can acquire the semaphore, and any thread can release the semaphore. Here the same thread is acquiring and the same thread is releasing, but I am going to show you how it can be done by different threads also. So the T1, T2, T3, T4, everything will only do the acquire, but release can be happened in another thread also. So I am deleting this release here, and the T1, T2, T3, T4 is only just acquiring the semaphore, but I am putting the release statement here. So once thread 1 is done, uh, main will so once T1 is done, that will be released. On T2 is done, that will be released, and T3 is done, that will be released, and T4 is done, semaphore is getting released. So I'm going to run this. So if you see, all the 3 have acquired, so 4th is waiting, and after 2-3 seconds, then only 4th is able to print this. So so here the T1, T2, T3, T4 are just only acquiring the semaphore, but release is happening. It is done by main thread. So as I already told, semaphore is just increment and decrement operation. It's like decrement and increment operation. It's not like mutex switch where the lock and unlock need to be done by the same thread. But here it's not the case. Any thread can acquire and any thread can release it. Here the T1, T2, T3 thread are acquiring, T4 are acquiring, and only main thread is responsible for releasing the semaphore. Thank you.